For those of you that factoring isn't their favorite, we're doing kind of a shortcut on factoring today, which is finding the difference of two squares. So when we say squares, we can mean like two things. We can mean like the shape square, but in the context that we're using it today is if you square a number, you multiply it by itself. So the difference of two squares is subtraction between two numbers that are being multiplied by itself. So we have a formula that we can follow to help kind of expedite or speed up our factoring process. So A and B stand for two numbers. If we have A squared minus B squared, we don't have to go through our whole factoring process. We can use a shortcut and say, well, the difference of two squares formula says, well, one of our factors is going to be A plus B. The other factor will be A minus B. And it'll always work out. So for example A, how I like to do these is I look, all right, x squared minus 25. To get x squared, that's like taking a x times an x. To get 25, I can take a 5 times a 5. So what that lets me do is now use my formula that's up there, where my A term is x and my B term is 5. So this is actually x minus 5 and x plus 5, and that is our factored answer. How I know this will work, if I was to use my box method, my middle term would cancel out. This looks like a quadratic, but it's missing kind of that term in the middle, our x term or our b term we would call it. That's because in our diagonal in our box, it would cancel out. For example, b, we're going to do the same thing. What can we multiply by itself to get 4z squared? Well, to get 4, I could take 2 times 2. To get z squared, I could take z times z. So this is 2z times 2z. And 1 is a perfect square of itself. I can get to 1 by just taking 1 times 1. So using the difference of two squares, I can say 2z minus 1 and 2z plus 1. Our last piece, look at 9m squared. 3 squared is 9. M squared is m times m. So this is 3m times 3m. And then 16 is 4 times 4. So I can write 3m minus 4 and 3m plus 4. And that's what we call our difference of two squares. And we're just factoring. We're now going to kind of use this to go through, and we're going to solve now for x. So this next example, solve the polynomial. X squared minus 36 is equal to 0. To get that, I would take x minus 6 and x plus 6. Because x times x is x squared, 6 times 6 is 36. That's right, x minus 6, x plus 6 is equal to 0. And since we have that equal to 0, like we talked about yesterday, we have to go ahead and get two answers out for x. So using our zero product property, we would say ZPP x minus 6 is equal to 0, x plus 6 is equal to 0. So our two answers, x would be a positive 6, x could be a negative 6. We'll try doing the same thing on B. 16, we get by taking 4 times 4. 16 is what we would call a perfect square. And h squared, can we do h times h? So we write 4h times 4h, because that's 16h squared. 49 we can get from doing 7 times 7. So this is 4h minus 7, 4h plus 7 equal to 0. So this is equal to 0, we have to solve for our variable. We're solving these. So using our zero product property, say 4h minus 7 is equal to 0. 4h plus 7 is equal to 0. Then if we were to go through and solve, it would be 2 steps. We'd add 7, divide by 4. So h would be equal to 7 over 4. This one, h would be equal to negative 7 over 4. In between these two, you may see a pattern. That when we have the difference of 2 squares, our answers for x will just be positive and negative of the same number. Positive 6, negative 6. Positive 74, 7 over 4, negative 7 over 4. That's always going to be true when you're doing the difference of squares. So problem number C, our middle term, or our B term, is back. All right, we have 3 terms here. So this thing is back. So what we'd have to do is, we would have to set up an x, and this is something we would try to factor. But again, this is going to have a kind of a special solution. I'm going to show you a big shortcut. What you could do is set up your x. 25 should go on the top. Negative 10 should go on the bottom. So what 2 numbers go on either side? How can we get a positive on the top but keep a negative when we add? Both negative. We make negative and a negative. It'll multiply to a positive, but add to a negative 10. And here's something you can do. When your A term is 1, you actually don't have to go through and factor by grouping each time. You got to skip all the steps that we did over the last 2 days. There's a big shortcut. My answer is going to be x minus 5, x plus 5 equal to 0. So I just take the 2 numbers that are on either side and plug them in to my factors. So we're going to go back for a second and look at old notes that we've done, and we'll see that this is always the case when our A term is 1. So looking back to, can we go back any farther than that? Let's go right here. So this was from 7.6 day 1, so something we did recently. We went through and we did the whole factoring by grouping process. In step number 2, we set up, all right, on either side of our x, we have 8 and 2. Well, our final answer, our factors are 8 and 2. And our second equation that has a 1 in it, so the one right below it, our A term was 1. We had 3 and negative 4 on either side. And our final answer, we have 3 and negative 4. This is just, I'm going back to show you that it always works, the pattern. We go back to what we did yesterday. We have our A term is 1 on either side. We have a positive 4 and a positive 2. Our factors end up being positive 4 and positive 2. So I don't even have to do factoring by grouping if I remember that pattern. And when my a term is 1, it's just the two numbers that are on the side of my x. So that leads me to know that this is, just right away without doing any work, x minus 5. And this one should be x minus 5 too. I didn't write it correctly. And we want to solve. So to solve, we have to use our zero product property. So we have x minus 5 is equal to 0, and x minus 5 is equal to 0. And both of these are the same, so we're going to get the same answer out. This x is equal to 5. Here, x is equal to 5 as well. Nope. Looking at our next problem that we have, we can't just use that shortcut because our a term is 9. But we could still set up an x. When we have 3 terms, your best bet is to start with an x. We can split it up by going, this would be a 9 on the top, a 6 on the bottom. Two numbers that multiply to 6, multiply to 9, but add to 6, 3 and 3. And there's 2 ways you could do this. You could do the long way, where you go through and you split your middle term and then you factor by grouping. So this would be 9x squared plus 3x plus 3x plus 1. You would group and group and group and group. You would go all the way through. I'm not going to show all the steps because hopefully we're comfortable with that at this point. And our 2 answers would be 3x plus 1 and 3x plus 1 is equal to 0. So then our actual final answer would be negative 1 over 3 if we set it equal to 0 and solved. Because we would subtract over 1, divide by 3, negative 1/3. The other way you could do this, kind of think about your difference of squares, so you don't have to do your whole factoring by grouping process. If you have 3 terms, you can always look at your first term and your last term. And kind of ignore the middle term for the time being. I know that my final answer should look something like this. I should have parentheses. I know everything's positive in here, so all of this should be positive. And I know I have 4 spaces to fill in my final answer. If I take this idea of, all right, what do I have to fill in here to get my first term equal to 9? Because when we use the box, we multiply our final answers together. In our box, this should be 9x squared. And this back piece should be 1. Both of those are perfect squares. So to get numbers that go here and here, this is 3x and 3x. To get to 1, this has to be a plus 1 and a plus 1. Well, look at, we knew that, we've talked about how factoring is the opposite of multiplication. It undoes it. So I know in my box, this could be 3x plus 1 and 3x plus 1, which is the same thing that I got when I did factoring by grouping. So this way would kind of be the grit and grind kind of way going through it, which is totally fine. This I would call the more conceptual, where think about what's actually happening and fill in the puzzle pieces from there. If you could do this, you're in great shape. If you could do this, you're still fine. All right?